first time hearing an engine startup leaves an everlasting impression on the mind. Those metal cylindrical tubes are the vocal cords of an internal combustion engine. It can communicate how many cylinders it has and if all of them are firing, whether the air-fuel ratio is too rich or lean, even if it's down on power. As critical as this component is, it's the most overlooked, commonly pieced together with no method of operation, and it can be the difference between power being lost or gained depending on the application. In this day and age, you have the ability to have it all the sound, all the performance, and all the comfortability configured into one system. And in this video, we will reveal the truths and falsehoods, the myths and methodologies behind building the perfect exhaust for your vehicle. The exhaust system is the culmination of many scientific disciplines like acoustics, fluid dynamics, chemistry, and thermal radiation. In an internal combustion engine, the exhaust stroke is the least mesmerizing, just clearing the path for fresh air and fuel to be drawn into the cylinder so the cycle can repeat itself. But the life of exhaust gases are just beginning. The exhaust isn't some solid stream of gas, but rather pulses. If you ever put your hand near a tailpipe at idle, you feel those pulses. These pulses comprise of positive and negative pressure, or compression and expansion. This duality is very important when it comes to the role in power production. If we put a pressure gauge on the exhaust port, you will see when the exhaust valve opens, the pressure in the port spikes dramatically as the gases escape. But something special happens afterwards. The pressure drops, and it drops to the point when it becomes negative or vacuum. Since the gases have mass and velocity, they also have momentum, which carry it downstream to the collector, and the negative pressure wave reflected back to the exhaust valve helps draw more air into the cylinder during the intake and exhaust valve overlap period. This phenomenon is known as scavenging, which is integral in the engine's ability to consume air or its volumetric efficiency. The velocity of those gases leaving the cylinder have a very important role as well. In fluid dynamics, a smaller diameter pipe will move an equal volume of gas at a higher speed than a larger diameter pipe, but with the downside of back pressure, which is the resistance to flow. Since engines operate through a power band and not at one speed, larger diameter pipes found in tubular exhaust headers are ideal for high RPM performance as they maintain exhaust gas velocity on the top end, but with a downside of poor velocity on the low end, negatively affecting scavenging, and the byproduct is poor torque production. The factory manifolds are the opposite. They maintain decent velocity in the lower RPMs for torque production, but become a restriction as RPMs increase and can even promote detonation in the cylinders since the back pressure is too high. The first area to consider for power output in your exhaust is the size of the primary tubing. A larger diameter cross-section allows for the least amount of back pressure and higher peak torque production, while a smaller cross-section has the absolute opposite effect. Using this formula for the primary pipe area, we plug in a desired peak torque RPM, let's say 6,000 RPM for a built K20 Honda engine. We multiply by the displacement of one cylinder in cubic inches, and then divide by a constant of 88,200. For the K20, we get 2.07 inches squared for the primary pipe area, and after converting the area to diameter, we get 1.62 inches, and after adding in the wall thickness of 0.065, you get the tubing size of 1 3/4 or 1.75 inches. These formulas are rough outlines and never should be used as absolutes, rather a rule of thumb. So if you're planning to build an all-motor K20 header and have 1.5 inch tubing laying around, you'll probably choke up the engine. So at least 1 3/4 and even 1 7/8 would leave more room for possibly bigger cams or nitrous down the road. The length of the runners also factor into the timing of pressure waves that are reflected back to the exhaust valve during valve overlap. Typically, a lower RPM street engine likes a longer primary pipe, around 35 to 38 inches, while a higher RPM racing engine prefers a shorter primary length, between 28 and 30 inches. And it's very important that all header tubes are as close as possible to the same length. Where they converge into the collector is another area of importance. This is where secondary scavenging can happen, as exhaust pulses exiting into the collector can help draw out the next adjacent pulse. Conventional 4-into-1 collectors, despite how simple they are made, give the best output for the effort. And while you can chase a couple horsepower by changing different collector lengths and diameters, you will have better results in going with more aggressive induction mods like higher duration cams, porting the heads, and adding larger valves to the equation. As we continue to work downstream, one age-old argument will rear its head: the X-pipe versus H-pipe debate. With V configuration and flat configuration engines, both cylinder banks need to be connected to balance out the exhaust pulses, and adding even another method of scavenging. X and H pipes connect the two banks, with the X pipe being a smoother transition that promotes better scavenging properties, and the H pipe being a 90-degree bend, which has lesser scavenging effect, but it's more cost efficient to install. In a now removed episode of Engine Masters, they tested a true dual versus H-pipe and X-pipe, and while the H-pipe made more torque than the true duals, the X and H-pipe were virtually identical. The real difference comes with sound between the H-pipe and the X-pipe. H is a deeper tone, while the X-pipe screams with a higher pitch, and it's purely personal preference between the two. After the balance pipe, you can route the exhaust directly where you want it to exit, but you're more than likely going to run into an annoying issue: droning. If you've ever driven a straight piped car at consistent RPMs, for example cruising on the highway around 2000 RPM, there's a frequency that the engine and exhaust system resonate together, and the constructive interference between them amplifies the sound, sometimes to the point of being unbearable. The goal of a resonator pipe is to use destructive interference, which aligns the sound waves 180 degrees out of phase to cancel the frequency. These come in different styles, but most notably J-pipes, which are tuned length pipes welded to your exhaust to be 1/4 of the wavelength, or 90 degrees out of phase, of the frequency of drone. And since the J-pipe has a capped end, the wave is reflected, now traveling twice the distance, and is now 180 degrees out of phase and cancels out the desired frequency thanks to destructive interference. To calculate the J-pipe length for your exhaust, there's some calculators and references I'll leave in the description, and it's not as complicated as it sounds. To quiet down the exhaust even further, different muffler designs will give you a desired tone and loudness, but also can affect power production. There's three main muffler designs. First, a reactive muffler, which is designed with chambers that deform the sound waves coming out of the engine. Absorption mufflers, that are commonly referred to as straight through, since you literally can see straight through them, and they quiet the sound with perforations and packing material. Reactive mufflers add an extra level of back pressure, slowing the velocity of exhaust pulses, and it will kill horsepower, but with the upside of harsh frequencies being tuned out, which in a more luxurious or grand touring vehicle is most likely wanted. The absorption mufflers are the least restrictive, and while not making as much power as a full straight pipe, they will make a noticeable power bump above reactive mufflers at the expense of being much louder and harsher. Something for a race-oriented vehicle like a street strip build or a Baja-style truck, or just simply you want to have a loud exhaust. Now, different styles of induction like supercharged, turbocharged, nitrous will all affect literally everything we talked about. For example, with a turbocharged application, you want the thickest wall tubing and shortest primary runner length to maintain the heat energy to impinge on the turbine wheel to decrease spool times, while also having a less restrictive outlet to create the pressure differential, which improves spooling as well. With supercharged and nitrous applications, you want even larger diameter primaries, since there's more pressure in the cylinders to be expelled and back pressure is more of a hindrance. This is why in some high horsepower factory applications like Hellcats, Z06s, GT500s, even exotics, they have valve diverting exhausts, which at full throttle open to let the exhaust gases bypass the chambers to lower the back pressure without adding more NVH by having an absorption style muffler. Valved exhausts are the absolute best at being the least harsh and lowest back pressure at higher RPM, and you do pay a premium for a valved exhaust since you're adding an extra mechanical or electrical component and can become an added failure point, which is very rare but still something to factor in. Also, if you reside in an area with emissions testing, a catalytic converter will be a necessity piece to pass inspection. Eliminating your catalytic converter in a factory application isn't really necessary. Most modern cats flow decently well. In a stock engine with minimal valve overlap, there's not much to be gained, and using a shorty style header can add power while keeping that catalytic converter. High flow cats can help, but depending on your modifications, they aren't guaranteed to pass emissions testing. So it's wise before even modifying to know if it's even worth it. No matter if you're running a little Honda 4-banger, an LS, an LT, a Coyote, literally any engine, it is important to understand how each part of your exhaust system will affect power so you can modify wisely. If you have a common platform like a Mustang, a Camaro, a Corvette, a Supra, there's already systems with all the engineering and math done for you, and they will fit without any issues. Now, if you're into Frankenstein builds and swapping engines into unsuspecting chassis, then this video will help you understand how to piece together an exhaust for your build and serve as a jump-off point for further research. If you like this style of video, let me know if there's any other topic you would like for me to cover in detail, and until then, take care, everybody.